Okay, ladies and gentlemen, today we're going to continue our discussion of the normal distribution, and we're going to look at the effect of shifting and rescaling the data, guided by our question, how are the center or position and the spread of the distribution affected when the data is shifted or rescaled? Apparently I cannot type, because this should say data. So looking at shifting the data is the idea of adding or subtracting a constant, which we will call C. So if we are shifting the data, we will see the distribution will shift position, so the distribution will translate left or right, depending if we're subtracting or adding. And this will have an effect on the center. The center will change and be affected by this shifting of the data. So the mean, the median, quartiles, and so forth. However, the spread of the data will remain the same. So the standard deviation, the range, the interquartile range will be unaffected by a shift. So if we were to write that out, we see we had our mu, we have a shift in place called C, so our new mu would be mu plus C. Same thing would happen to our median, so if we had a Q2, we shifted, we would get a new Q2 of plus C, of Q2 plus C. But our standard deviation would remain the same. Our range would also remain the same. So shifting data, adding or subtracting C, will affect the centers, mu, the median, but will not affect the spread. Now rescaling the data, that involves multiplying by a constant. Again, we'll keep it as C. When we multiply by a constant, we're going to affect not just the position, but we will also be dilating the graph. So we'll be stretching it or shrinking it. So we're going to see both the center and the spread affected. The center will change, the spread will change. So looking at it mathematically, originally we had our mu. We're multiplying by C. Our mu will be C times mu. Same thing with Q2. Q2 would then also be multiplied by our constant. And unlike shifting the data, rescaling the data will affect the spread. So the standard deviation will also be multiplied. The range would be multiplied. So the walk-away thing to remember here, shifting the data affects only the measures of center, but rescaling the data, the multiplying or dividing, affects both measures of center and measures of data. Measures of center and measures of spread. So now let's go ahead and look at an example. Here we have a group of 5 friends. They own chickens. And so we're going to compare their number of chickens. So to create a distribution that we can examine, we'll go ahead and make a dot plot. The data is really small, so making a histogram or stem and leaf plot here really would not be useful to us. So we will go ahead, make a stem and leaf dot plot. So we get 0, 2, 4, 6. And this axis is measuring the number of chickens. So we have 2. So we're going to plot our data. We got 1, 2, 3, 3, and 4. And so we can see that this data is unimodal. and is symmetrical. So the normal model, the normal distribution, does apply. And so let's go ahead and look at what our center statistics are. We know that we can go ahead and calculate our mu. So that's going to be 1 plus 2 plus 3 plus 3 plus 4 divided by n, which is 5. And that's going to give us 2.6. And mu has units, so it's 2.6 chickens. Okay. Medians would also remain the same. In this case, our median would be 3. But we're going to concentrate, since we're looking at the normal distributions, we're going to look primarily at the mean. So let's go ahead and do our spread statistics. Now we're going to use a calculator to find our standard deviation. This one would not be too difficult to do by hand, but so we find out that our standard deviation is 1.01, actually 1.020, also still chickens. And our range would be 4 minus 1 or 3. So here's our basic data. We can see it's unimodal. We see our mu, and our sigma. So let's look at if we were to shift the data. So what if each friend went out and bought 6 new chickens? So if each friend went out and bought 6 new chickens, well, that means each friend, so 1 now is 7, 2 is now 8, and we have 11, I can't add, 9, let me erase it, rewrite that. So it would be 9, 9, and 10. So we'll go ahead and plot that and take a look at it. I'm not going to draw the tails just for time purposes. So we've got 0, 2, 4, 6, 8, 10, 12, and 14. So if we plot our original data, just so we can see a picture, our original data was 1, 2. We had 2 dots at 3 and a dot at 4. So now to plot our new data, we've got 7, 8, 2 at 9, and 10. So as you can see, the data remains the same, but we took the green and translated it, shifted it to where the blue is. So let's look at how that affects our data. So our mu is now should now be 8.6. We added our original mu, 2.6 plus 6 to give us 8.6. But if we were to calculate it out, traditionally, just to see if it works, we'd have 7 plus 8 plus 8 plus 9 plus 9. Oh, sorry, there's only 1 8. I'm rushing ahead. So 9 plus 9 plus 10. So 18, 26, 33, 43. So 43 divided by 5 would in fact be 8.6. So that does show the data is same. But because if we look at this, we look at these two pictures, the data hasn't changed. If we were to pick up the blue, we could put it directly down on the green, it would match up. So our spread, our standard deviation is going to remain the 1.020 chickens. And we can see that the range remains unchanged as well, because before it was 4 minus 1. Here we have 10 minus 7. And 10 minus 7 is still 3. So you can see, just causing a shift, The centers changed, but not the spread. So now let's look at a rescaling. So instead of each person going out and buying six new chickens, they went out and bought 4 times their number of chickens. So our new data would be 4, 8, 12, 12, and 16. I'm going to have to rescale my graph a little bit because I need to go all the way to 16. So I'm going to go with 16, 14, 12, 10, 8, 6, 2. And I'll go ahead and use red here. So we've got 1 at 4, 1 at 8, 2 at 12, and 1 at 16. So we're still seeing unimodal, and we're still seeing symmetrical. But now, instead of the data points being close together, they have been spread out. What is that going to have an effect? Well, let's look at the mu. Mu would be 4 plus 8 plus 12 plus 12 plus 16, which is 12 plus 12, 36. 36 and 16 is 52. 52 divided by 5 is going to be 10.2. So let's look at it. An idea, we multiplied it by 4, so we had original mu was 2.6. We multiply that by 4, we get 10.2. Our spread is also being multiplied. So our original spread was 1.020. We're going to multiply that by 4, and we get 4.080. So we can see the spread has changed. The range also affected in the same way. This would have been 16 minus 4, which is 12, which so happens to be our original range times 4 is also 12. So now we've seen how a shift happens or a scaling. How does both? Would both happen? So keeping with our same scenario, this time we got the chickens, but this time the friends went out and bought 3 times the number of chickens they had, but the farmer loved them for buying all his chickens, so he gave them all 4. So our new data, we'll go ahead and use, we'll use purple this time. So our new data, so the 1 times 3 plus 4 is 7. 2 times 3 is 6 is 10. 3 times 3 is 4 is 13. We have another 13 and 12, and we still have 16. Okay, so drawing our distribution here. Okay, I'll call this one 16, so 14, 12, 10, 8, 6, and 4. Go back into purple. We'll go ahead and draw the plot. So 7. That is not 7. That is 9. So 7, 10, 13, 13, and 16. So we're still looking to be unimodal. And we are still symmetrical. But this time we have shifted the graph and dilated it. So if we go and look at what that would do to the measures of center, our new mu, because it's center, both happen to it. So we have to do the 3 times the original mu, which is 2.6, plus the 4, We got 7.8 plus 4. So our new mu would be 11.8. I did my math wrong. All right, our new spread's not affected by a shift, so we only have to take our original 1.020. We're going to multiply that by 3, which gives us 3.06. Same thing happens to the range. Again, it is not affected by the shift, only by the dilation, the multiplying. So we take our original range of 3, multiply it by 3. Our new range is 9, which we can see is 16 minus 7. So I hope you can see with that the idea of it shifting and rescaling with shifting and rescaling and data shifting and rescaling. Shifting is we are adding, rescaling we are multiplying. So that brings us one thing. Several of the exercises you're going to look at going forward as we continue this are going to be asking for unusual values. Values that stand out. In other plots, thinking about the outliers. Well, in a normal distribution, those outliers are the things that are outside of 2 standard deviations. So outside, so we're looking at this tail, and we are looking at this tail. We know from yesterday that each of those represents 2.5%. So we are looking for unusual values are going to be values with probabilities greater, or sorry, the probabilities of less than 5%. So we're out in those tails, and they are defined. Unusual values are going to be defined as those x values whose z-scores are greater than 2 or less than -2. So this side over here, our z-score is less than -2, and on this side, our z-score is greater than 2. So those things, so we're outside of that 95% in between here, and we're looking for that. Those are the unusual values. So, ladies and gentlemen, you've got that good. Everything's looking good. So you've got your assignment today, first worksheet. Make sure you're coming into class Thursday, Friday, ready to discuss it with any of your questions. Thank you.